In this video, we'll see how you can use GroupBy to partition a data frame into groups and subsequently aggregate or transform the data in each group. To start, let's build a data frame with 4 columns, A, B, C, and D. By the way, .convert dtypes is a handy way to make sure we're using Pandas' modern string and integer data types, which allow for NaN values. Without it, A would be type object, and D would be type float64. Every GroupBy operation starts with a call to the GroupBy method. Perhaps the most important parameter of GroupBy is the by argument, which tells Pandas how you want to split the data frame into groups. Usually you'll specify one or more column names here. For example, df.groupby open parens by equals A tells Pandas you want to partition the data based on unique values in the column A. In this case, Pandas partitions the data into 2 groups like this. Alternatively, you could do df.groupby open parens by equals list A, B to partition the rows based on the set of unique A-B pairs. In this case, Pandas partitions the data into these 3 groups. The result of calling df.groupby is a special type of object called a DataFrameGroupBy. Now, I should note that you can also call GroupBy on a series, in which case you'd get back a SeriesGroupBy object. DataFrameGroupBy and SeriesGroupBy are both extensions of a generic GroupBy class, so they behave very similarly. GroupBy objects have some special features and attributes like .groups, which returns a dictionary of group key : list of input rows pairs. For example, if we set groups_AB equals df.groupby open parens list A, B, then groups_AB.groups tells us that rows 0 and 2 correspond to the key foo, false. Similarly, groups_AB.ngroup tells us the numeric group ID associated with each row of the input data. Notice that these group IDs are ordered by the order of their keys. For example, group 0 corresponds to the key bar, true, because alphabetically bar comes before foo. But in the original data frame, the key foo, false is the first one to occur. So if you'd rather have the groups ordered by the first occurrence of each key, you can do so by setting sort equals false inside the call to GroupBy. For example, if we set groups_AB equal to df.groupby open parens by equals list A, B, sort equals false, and then we call groups_AB.ngroup, you can see group 0 occurs before group 1, which occurs before group 2. Another thing we can do is, instead of passing a list of column names into the by argument of GroupBy, we can pass in a series, in which case the series values determine the groups, and the series index determines which rows of the data frame map to each group. For example, if we want to group the data based on the whole part of the values in column C, we could say holes equals df.c.apply open parens np.floor, which returns a series, and then df.groupby open parens holes. In this case, the values in the series get partitioned into 5 groups. Then the index labels of the series tell Pandas how to map the rows of df into those 5 groups. Index 0 goes to group 1, index 1 goes to group 0, index 2 goes to group 2, and so on. Note that typically this would be written as a one-liner like this. Partitioning data into groups isn't all that useful until you actually do something with the groups. Usually after you group some data, you follow it up by aggregating the groups or transforming them. Let's start by looking at some GroupBy aggregate methods. We've already seen how to aggregate an entire data frame down to one row. Aggregating a GroupBy object is essentially the same thing, where the aggregation applies to each group of data, and then the results are combined into a data frame or series. The best way to get a feel for how this works is to do some examples. Let's start by grouping df by column A, and then aggregate the groups taking the sum of column C. One way we could do this is df.groupBy open parens open quotes a square brackets open quotes c dot sum. Alright, let's break that down. df.groupBy open parens a creates a DataFrameGroupBy object. Tacking on square brackets c isolates column c, returning a SeriesGroupBy object. Now keep in mind DataFrameGroupBy and SeriesGroupBy are both derived from a generic GroupBy class. So if we look at the documentation for GroupBy, we can see that it includes a sum method for taking group sums, which is what we do here. The result is a series whose index labels are the group keys and whose values are the group sums. Here's a similar operation, except here we wrap C inside of a list. In this case, Pandas doesn't convert the DataFrameGroupBy object into a SeriesGroupBy object when we pick out column C, and as a result, we get back a data frame of group sums instead of a series of group sums. This is analogous to doing df square brackets open quotes c, which returns a series, and df square brackets list c, which returns a data frame. We could also use this technique to calculate group sums for multiple columns. For example, df.groupBy open parens a square brackets list c comma d dot sum returns a data frame with sums over d and c aggregated by unique groups in A. We could also replace .sum here with .ag and pass in a method name or function callable. Basically, everything we learned when we covered data frame aggregation can be applied here, which means you can even do things like this to get the sum of C and the mean and variance of D for each group in A. Note that the resulting data frame here has something called a multi-index for its columns. Similarly, if we did df.groupBy open parens by equals list a b square brackets list d dot mean, we'd get back a data frame with a row multi-index. We'll cover multi-indexes in a future video, but for now just know they exist. If we group by b and d, taking the min and max of c, you'll notice that Pandas ignores and drops the nans inside D. Personally, I think this is a really unfortunate default behavior, but you can turn it off by setting drop in A equals false within the call to GroupBy. Another question that comes up a lot is how do you rename the output columns? So let's say you wanted to do the same thing as before, but you want the output columns to have names C_min and C_max. In this case, you can pass named tuples into the ag method like this, where the keywords become the column names. Now let's look at some GroupBy transform operations. For example, suppose you want to sort the values in column C, but only relative to each group in A. One way we can do this is df.groupBy open parens A square brackets C dot transform open parens lambda x colon x dot sort values. Let's break that down. df.groupBy open parens A square brackets C groups the data by column A and then isolates column C. Next comes the .transform bit. The transform method takes one primary argument, which is the function you want to apply. In this case, sort values isn't a built-in GroupBy method, so we have to pass it in as a function callable. Here we've done it using lambda, a useful construct because you can use lambdas to make all sorts of custom functions on the fly. But we could actually just reference the sort values function directly from the series module. The result of this operation is a new series whose index matches the row index of the original data frame. This is useful, for example, if you want to tack this on as a new column of df, or overwrite the existing values in column C. For example, if we add this as a new column called C_sorted_within_A, you can see how the new values compare to the old values. Now, as you probably guessed, if we do the same exact thing but we wrap C inside a list, we get back a data frame with essentially the same exact data. Let's look at another example where again we group by column A, but this time we calculate the mean of columns C and D. Like before, df.groupBy creates a DataFrameGroupBy object. Then we pick out columns C and D, giving us a slightly different DataFrameGroupBy object. And then we call .transform, passing in mean, which we can do because mean is one of the built-in GroupBy methods. And at this point, you might expect the result to have fewer rows than the input, because mean is an aggregation function. But to the contrary, the result is a data frame with the same number of rows as df. And this is the important thing to understand about the transform function. The output rows will always match the input rows, and this is in stark contrast to the agg function, in which the output row count is usually much less than the input row count. In this case, the mean of each group in A was broadcast to match the length of the original data frame, which is why you see a bunch of repeated values in the output.